A straightforward way to figure out the energy needed or released during a chemical reaction is by analyzing bond energies. After all, some bonds get broken, some bonds get made. The one thing you want to get straight is that it takes energy to break a bond, like breaking a stick, but non-intuitively, it releases energy when you make a bond. So for example, if you're making nitrogen in a chemical reaction, which is triply bonded and extremely strong, you might have an explosively strong chemical reaction. Try nitrotoluene, for example, generates tons of nitrogen when the reaction goes forward, and it's very exothermic. So bond energy, let's take a look at some hydrogen to hydrogen bonds, some oxygen to oxygen double bonds. Note that's stronger. Hydrogen to oxygen single bond, and let's apply these to burn some hydrogen and make some water. So let's find out what it costs per mole to make some water. There's the balanced chemical equation. Looking at this quickly, you should be able to see we got a break for each molar process. That means 2 moles of hydrogen, 1 mole of oxygen, etc. We better break 4 moles of H to H, 1 mole of the oxygen double bond, and we're going to make, well, each one of these has 2, so we're going to make 4 moles worth of HO bonds. That's where the energy released will come from, and if that can overcome the energy that goes into it, it's exothermic. And when you're burning hydrogen, I'm pretty sure that thing gives off energy almost instantaneously. Okay, so let's draw all the bonds there. Here's a nice visual where I drew everything out so you can clearly see it. If it says 2, I wrote 2. Let's put the numbers underneath. We've got to put an 872 there, another 498 there. What do we get back from it? 4 times 4, 64. Notice I make those negative. Add them all up, and you get a negative 486 kilojoules for this process. That means when you burn 4 grams of hydrogen, right, 2 grams per mole, plus the 32 grams to make 36 grams of water, it'll release that much energy. Is it a lot? It certainly looks like a lot. I like to compare it to nutritional calories just to get a quick check on it. Burning 4 grams of hydrogen, that's 2 moles, will release 486 kilojoules of energy, but since there's 4,184 joules in a nutritional calorie, it's not that much. It's really only 100 nutritional calories, and that's an energy unit that most people are very familiar with. That's a look at bond energies.